Focus, there we go. Sorry about that. Okay, fantastic. So what we're going to be doing here is looking at the turbulence set. So let me get this going quickly. Again, sorry for the delay. Now, the first thing you want to be doing with your set is, let's open this up here. Okay, now we need to have the table protector, okay, which is this black set here, this black mat. Now, the reason we're going to be doing that is because we're going to be working with liquids, okay, and we don't want to damage the table. Now, what I found is the easiest way to do this is if you get the set here. Sorry, let me move this camera back a little bit. There we go. It's nice and clear. What you can actually do is it's rolled up. If you flip it over, it should sit nice and clearly onto the table. Okay. Now, where do the sewers lead to? Asked Thomas. I'll get into that in just a second. Let me start doing the set, and then we can have a look at it. Now, also within the set here. Okay, there should be some gloves. So I'm going to get all of the bits out. Here we go. There we go. Now within the set, there we go. And now you should find the gloves within the little cups here. So can you make sure that you guys are wearing cups, please? Sorry, gloves, not cups. Wearing the gloves. There we go. So I'm just going to pop those on now. Now, one of the questions that's been asked, okay, that's a really, really good question, is where do the sewers lead to? Now, the sewers in most cities, now they used to lead out to rivers and things like that and stuff. The problem is those rivers started to get pretty dirty, okay? They ended up getting pretty dirty, and I have to say, not very pleasant for us. And in fact, in London here, we had the River Thames. We have the River Thames, and that ended up getting pretty filthy. And in fact, if anyone ever fell in there or went swimming in there, it would be pretty bad news for them. They would get very, very sick. So what now happens is we have the sewer systems are connected to large sewage treatment centres. Okay, and essentially what they do, these treatment centres, is they clean all of the water. They actually end up taking out all the bad material and treat them. Now, some of our other sessions actually deal with this, but I will... fantastic. Yeah, they get polluted. Yeah, the fish will eat it. It's bad for them. That's absolutely right. Well done. Yeah, it's bad for nature. Absolutely right. Okay. So, okay. Right, what we're going to do here is... okay, now... I've got these 3 bottles that should come with the set here. Okay, we've got one that is empty. Okay, and that will be water. Now you're going to need some water. Okay, you can just use normal tap water for this session, but as I say, we're also a little bit later on. Okay, a little bit later on, you're going to be also needing a kettle of boiled water. Okay, now what I recommend you actually set it off to boil now, so that when we actually use it, it is not boiling. Okay, fantastic. Good. Yeah, Massa said, I love nature. I once cleaned up lots of garbage and filled 1.5 trash bags with... Yeah, fantastic. Well done for doing that. All right, brilliant. So, as I said, what we've got here is we've got our 3 bottles. Now, one contains glycerol and water, and one will contain the water. Now, it is our job to supply the water to these. Okay, so the first thing we do is take the lids off these. Now, let me make sure... There we go. There we go. Take the lid off there, okay, for the water. And I've got a bottle of water here, okay. So now this is just tap water, but now what I'm going to do is fill that up there. Okay, nice and carefully. Now please be careful not to spill. Perfect. And I'm just filling it up to this part here, okay. Fantastic, and then I can put the lid on that. Now that will be the water, okay? Now actually I'm not putting it on too tight because we're going to be adding stuff to it in just a second, but I just want to make sure just in case I tip it over. Now this one here is the glycerol and water. So again, what I'm going to do is add water to this just to get it up to this layer here, this level here. Okay. Now water flows pretty easy, but glycerol is a lot thicker. It is more viscous. Okay, now just very quickly before we get into this, now I'll let you guys, anyone who's doing it with me, setting up. Okay, yes, water is H2O. Well done, fantastic. Just understand this, right? There is around us okay, our atoms are everywhere. Now, what are atoms? Now, atoms are tiny little things that you can't even see even under a microscope, but yet they are all around us, okay? And they fit together kind of like building blocks to make larger structures. Okay, so for example, owlie is made of atoms. Now, atoms are so tiny we can't even see them under a microscope, so they're basically invisible. But yet, owlie and me and you, everything around us, are made of atoms. So why is it that we can see owlie? Why is it that we can see... I can see you, owlie. Wait, can you guys see owlie? He's not just an imaginary friend. You can definitely see him, right? So, this is awkward. Yes, you can see him. Okay, phew. Okay, cool. You're not just an imaginary friend. That's excellent. Right, so you guys can see owlie, and he is made of atoms. And now atoms are basically invisible because they're so small. Why is it that we can see owlie? Why is it, if he's made of these things that are so small that they're basically invisible, that we can see him? What is going on there? What do you think? Now, you can pop your answers into the chat. Now, I know some people are a bit shy about writing into the chat, but you know, feel free. And I can see some popular. So Ebne's popped it into the Q&A. Are atoms God particles? Not quite, Ebne. But I'm happy to go into that, and I'll come back to that Q&A question if we just leave it in the Q&A. Cashin, that's okay to say. I don't know. Yep. Because he's made of lots of atoms, says Raina. Any other answers? They clump up and the structure gets so big, it's like billion times bigger than an atom. Massa, great answer. Same with you, Rena. Or Raina. Or Rayana, sorry. That's big enough to be seen. Yeah, well done. I can see lots of other answers coming in. Absolutely right. All of you guys are absolutely right. So essentially, he's made of lots and lots of atoms that essentially clump together, that fit together to make larger things that we can see. The atoms connect to make a bigger structure, says Liam. Absolutely right. Well done. Fantastic. What great answers, guys. That's right. So we can see owlie, even though you're made of invisible things. Yeah, phew, we can see you. That's excellent. He's made up of visible matter, says Cam. That is fantastic. Well done. And massa's a billion trillion. Yes, absolutely. He's made of millions and millions of atoms. Thanks, buddy. You'll come back in a bit. Thanks. Yeah, he's made of millions and millions of these atoms that fit together so we can see him. Now, liquids are also made of atoms, and so is the air around us. So if you wave your hand at your face, okay, you can actually feel atoms hitting your face. Try not to hit your face. You can feel the atoms. Now, we call that wind or air moving, but essentially it is atoms that are moving. Now, I'm looking out the window and I can see the trees moving outside. And essentially, those trees moving is because they are being hit by lots and lots of atoms that are in the air. So the air around us contains lots and lots of atoms. And listen, so this is the really important part to understand here, that atoms and molecules, fluids, so any moving liquid or air, essentially, or waste products like other gross stuff that goes down the lavatory or toilet, as substances move past each other, there is a force called friction, and friction slows down moving objects. It's the same reason why in a really, really fast sports car, they make sure the car is very, very aerodynamic, so it sort of cuts through the air much more easily, so it's not being hit by so many air molecules, okay? So essentially, friction opposes motion, and this can cause a change in the amount and direction of the movement, and that is what happens. So we're going to actually explore that, which is really cool. And by the way, the word rheoscopic, okay? So rheoscopic fluid, what it actually means, rheoscopic, is current showing. It's the showing of the currents that we see. Just like in the water, we get currents of water and things like that, stuff in the sea. The same thing as wind in the air. These are currents, but we're actually going to show them, which is really, really cool. Okay, right, so let's do it. I know it's a little bit of talking. Now, within the sets, you will have the green metallic coloring, okay? And we also have the blue metallic coloring, and we've also got the purple or violet metallic coloring, and we're going to add these to our bottles. Okay, so let me make sure I can, there we go, tabletop, there we go, fantastic. Right, let's do them. So we're going to add them to the colors that are there. So into the green one, we're going to put 2 spoonfuls of the green metallic fluid. Now, right, now within my set, okay, so within here, you should see there is a little white spoon there, okay, a little white spoon, and here it is here. So what I'm going to do is I'm going to add 2 spoonfuls of the green metallic coloring, which is very cool. This is metallic, so metal like colouring. There we go, which actually makes a really cool colour. So I'm going to put 1 and 2 in there. Okay, don't worry if you spill a little bit on the table, that's what this covering is for. Okay, now here we go, I'm going to pop the lid on that. Now we can actually see it starting to sort of spread out there. There we go, we actually see it moving, which is very cool in itself. Right, we're going to get the blue one here. Now this is known as a suspension because it will be suspended within the liquid, which is why we can see it. I'm going to just put 1, 2 there. Actually, I didn't fill up the second one very much. There we go. Perfect. So that is 2 of the blue, 2 blue. Okay, and I'm going to put the lid on that nice and tight. Okay, so just make sure you've got the lids nice and tight because we're going to end up moving them around quite a bit. So there we go. I'll let you turn those. And then the last one in the violet one, which is just the glycerol, okay, which I haven't opened already yet. We're going to put the violet or purple metallic colouring into there, which is pretty cool, actually. There we go. That's 1 and 2. There we go. Fantastic. So let's have a go at these. Right. How are you guys getting on at home? So for those of you guys doing this too, are you able to do this? Now, do you see this one didn't spread out? It's easy. It's just sitting there on the top. Whereas this one here, this is now starting to spread throughout. And this one here, same thing. Okay. Well done. Perfect. Now, Massa said millions of atoms are hitting the tree, like the tree, like in Jupiter's atmosphere. Right. Yes, because it's moving and you can see it, the movement. Exactly right. So in fact, we're actually going to be looking at Jupiter and why it looks the way it does in just a bit. Okay, so the current is flowing. Now, what we're going to do is we start to spin these. So watch this. If I start spinning this round, okay, so I'm going to get that mixing. Okay, now if you're doing this at home, have a look what happens. So look at this. We can actually see the currents flowing in there. Now look at this flow here. It's actually very, very cool. Look at this. Now, are you able to get something similar at home? How that, yeah, it looks like a spinning top, that's right. But look at them, you can actually see, now what's actually happened is the flow is still going, but it's slowed down dramatically, and that is to do with friction, okay? And that's in the bottle, yeah. It is very cool. I can see Thomas saying, whoa. Yeah, these sets are very, very cool. Look at this one. But let's have a look at the blue one now. Now, it hasn't quite mixed properly. Remember, we've got glycerol and water in there, so I'm going to just shake it around, and then I'm going to start to spin it. Now, have a look at this one here. Look at this amazing flow. You can see them sort of moving around here in comparison to the... Now this one here are actually quite separate. You can sort of see the layers don't really mix with each other. Have a look at this one here. And we can actually see that the layers starting to mix a lot more freely. They're kind of... But let's have a look at this last one. So I'm going to mix up the violet one or the purple one. I'm going to spin this. Now I'm going to try and spin this one. But look, there's almost no movement. Watch, I spin it, spin it, spin it. Ali's going, you're not spinning it hard enough. But look, there's very little movement at all within this one. Now, that is to do with the viscosity. Okay, so the viscosity, now, viscous is just really a fancy way of saying how thick a liquid is. So for example, honey is very, very viscous. Same with syrup. It takes a while to pour, whereas water pours very easily. Now what we found is that fluid particles, okay, so the atoms within a fluid, okay, will, within things like water and stuff, okay, and also within the air, they will follow very, very clear lines. It's almost as if, now we call that laminar flow, okay, so don't worry too much about the posh sounding words, but I'll be asking a poll in just a second. Laminar flow. It's almost as if, you know, if you take a deck of playing cards, you know, that magicians use, you take the deck of cards and you just let them slip, you'll sort of see that the cards kind of go down in straight lines. In the same way, what happens when we spin this water, metallic water, what you get is you get these lines where they essentially stay very much in line with each other. And that's when a fluid is very unviscous, or very, essentially, where it's not so thick, okay? But with very thick liquids, okay, so more thick liquids, what you actually get is you get what we call turbulence, where these layers start to kind of move between each other. And in fact, with this glycerol, it's so thick, so viscous, that actually there's almost no movement whatsoever. So again, today in this session, this kit is really cool because what what I love about it, and what Ali loves about it too, is it gets us to really see what's happening when liquids become more viscous. And by the way, this is really, really important for the people who design these sewage systems, for people who design the airflow systems in buildings. It's really, really important to understand. Okay, right, fantastic. Friction on the sides of the bottle, right, says Massa. Absolutely, viscosity, yep. Water has petroleum, super high, liquid helium. Fantastic, lovely answers. There we go. Brilliant. Now, I'm just going to do a little poll for you guys. What is laminar flow? Remember, that's like the cards, okay? So a little poll for you. What is laminar flow? Is it where either gas or liquid flowing over an object throws out lots of little eddy currents? Or is laminar flow, remember it's like the cards, is it where either the gas or the liquid flowing over an object flows smoothly without any perturbations? Now those are the kind of like the ones. And then by the way, I don't need you to get these right. It's okay if you just guess, that's okay, but I just want to get you off. Is it where either a gas or liquid flowing an object stops suddenly? Or is it describe the movement of a car tire through a muddy puddle? That's pretty cool. So what now? I don't need you to get these right, okay? So please don't worry. But it's more just to check that you guys are there, that you're alive, that you're concentrating, that you are awake. Just seeing. So as I say, you can guess. That's no problem. Don't worry. I promise I'll go over the answer. And by the way, I don't know who clicks what. And I certainly won't say, I can't believe you didn't get it right. Just have a go. All right. Now I can see that almost all of you guys have answered. If there's anyone else... Now, Massa said the atmosphere in Jupiter is the same movement as the blue bottle. Yes, that's right. Well done. And we'll be talking more about Jupiter in just a minute. Perfect. So let's end the poll there. Okay, now, so I can see that most of you guys have put where it's either a gas or a liquid flowing over an object flows smoothly without many perturbations. Now, essentially, that's just a fancy way of saying without all those little eddy currents. That is the correct answer. Now, as I say, I didn't need you to get the right answer, and I don't know who clicked what, so it's okay. Yes, the first one is an object throws out lots of little eddy currents. Now, in fact, so for that first answer, so if you have a fluid flowing over an object where it throws out lots of little eddy currents, okay, right, that is known as turbulent flow, because all these little eddy currents are the turbulence. So in this blue bottle, here we go. So thank you very much, by the way, for answering. Thank you. Awesome, guys. So what's going on in this blue bottle is this is known as turbulent flow because we're getting lots of these little kind of eddy currents, whereas with this one here, it's laminar flow where they're just going in lines, linear flow, laminar flow. All right, fantastic. We're going to go on to that a little bit more in just a second, okay? So let me just quickly show you this diagram here. Correct. Well done. Okay, brilliant. So that is that's these ones. They're pretty cool. Okay. Now, what you can also do, and I do recommend having a look at this, is you can pour a small amount of these into a little here we go, into a little petri dish like this, and actually investigate how they move. So what I'll do is I'll take a little bit of this water here, okay, and I'm just going to put some into this. Okay, and what you can actually do here is within the set we've got a little wooden, there we go, little wooden column, there we go, and what you can actually do is if you run this across, what I'll do is run this across here and you can actually see what happens. Now what I advise you to do, if you have a camera, a smartphone that does slow motion, okay, as many do, I'm going to just quickly do this in slow motion just to show you. Okay, now what I will do is I'll just show you this. You can actually see, there we go, it's not perfectly, look at all those, can you see all the little eddy currents that are in there? Let me play again for you, and Now watch as I run the stick along, look at those, all those little eddy currents that are there in slow motion. So I do encourage you guys to do this yourselves at home, okay? If you have a smartphone or your parents have a smartphone that does the slow motion, have a look at it, but also have a look at the video, and you can do it slowly. Most people should have some form of device that allows you to at least make a video of it. And if you do make any videos or any pictures like that, please do send them to us. We love seeing them, and just put the hashtag MELScience or MEL Academy at melscience.com. Fantastic. So that's the green one, but have a look at what happens with the blue, and have a look at what also happens with the glycerol as well. Okay, those are very, very cool. Right, now I'm just going to pop this over to one side, and we're going to get going with the second one. Now, obviously, we've been going through a lot of the science here, but I want to make sure that we have enough time to get through all of this. Now, we're going to be looking at convection cells. Now, remember I told you that we're going to need your the kettle. We're going to need some warm water, okay, some hot water. Now, what we need to do is we're going to take our bottles, okay, and we are going to place them into the Petri dishes. Okay, so what I'm going to do is I've got one with the green, and in fact what I'm going to do is I've already sort of done this, is I will fill this up just a little. In fact, what I need to do is make sure I really do shake it up. Okay, there we go. Now I'm also going to do that with the there we go, with the blue one, which is a mixture of the glycerol and water. Okay, let's have a look at this, and we're going to pop that into here. Okay, these are very cool, especially with this metallic colouring, I have to say, guys. Really cool sets. Well done to the MELScience guys for discovering these. I think they're really cool. All right, let me make sure I actually shake this one up. Sorry, nearly forgot. There we go. Look at that one. That is much more viscous, very much thicker. There. Okay, and as I said, look, you can run your you can actually sort of run your stick across the top of them and have a look at the sort of turbulent flows. So again, with the green one, actually, we're getting a lot more of kind of turbulent flows here, and with the blue, we still get some. But with this one here, we get a lot more laminar flow, which sort of stops dead. There we go. All right, perfect. So now what we're going to do is we're going to need the cups. Okay, these little cups here. And this actually happens pretty quickly, so we're going to need to be careful to really keep an eye on it. I've got my recently boiled water here, and so what I'm going to do is I'm going to pour that hot water into these cups here. Okay, so I'm just going to fill the cups. Now, please be careful and get a responsible adult to help you with this. And what I'm going to do is I'm going to place the green one. In fact, what I'll do is I'm going to place the violet one, because it's a little bit closer to the screen, onto the top. Now I want you to watch it very carefully what's happening here. Okay, now you should see something to start happening as it's warming up. Okay, so we'll just have a look, and if you're doing this at home, have a look and also take pictures, which is very cool. Now what I'm going to do is I'm going to be very careful, and I'm going to place the blue one onto the, there we go, to the hot water. And I'm also going to place the green one onto the water too. Okay. Now, what we should get, it depends on how hot. So my water's cooled down a little bit because I've done this at the beginning, which does slow the process up a little bit. But I can already start to see some change to the liquids. Now, what are we expecting to see? Well, now sometimes they can be pretty quick. The green one should take about 15 seconds, the blue takes about 30, and the purple one will take about 1 minute or so. Now, what are we expecting to see? That I'm just going to quickly go onto this. Now you can actually see this with the blue one here, that we're actually getting these little I'll take a photo here for you. We're getting these sort of little round patches here, these little kind of sort of round patches starting to form. Okay, We're getting these like little round sort of patches, and what will happen is the same thing will start to happen with the purple one too. Now it's pretty cool. It's pretty cool to see in person. Obviously it's a little bit hard to see over the camera, but what is going on? Well, let me show you this. So at the tabletop, and I'm just going to take the hot water here, but as I said, please be careful. I haven't let it go all the way, let it boil too much, so I've just set it to not go too hot. There we go. Right, let me make sure I've done this. Okay, right, now what we're going to do here is I'll pop the violet one, because now what we'll see in the violet one hopefully is quite quickly, and I'll make sure I take a picture for you guys as well, we should quite quickly start to see these sort of bubbles starting to form, and I'm going to do the same thing here with the blue as well. And we'll see these little cells starting to form, and the green will be much quicker. Okay, now I can already start to see movement kind of on the surface here, and there we go. Yes, there we go. I can sort of show it to you on the, there we go, on the blue one there, which I think is probably the best. There we go. Right, so what I'm going to do is I'll just show you, here we go. We can actually see the movement there. Hopefully you'll be able to kind of see that nice and clearly. I'm sorry that I have to do it via the video, but look at that. You can kind of see that movement there as they're sort of moving around. It is very cool. All right, brilliant. Now, if you do, as I said, now we can already start to see it with the purple one too here. I don't know, hopefully you guys can actually see that yourselves. Look at these, okay? Now these are the Raleigh-Bernard cells, okay? And they form in more viscous liquids. There's almost no liquid transfer between each cell. So as I said, what's going on here is that I'll show you the wonderful one with the purple there, it's actually moving beautifully there, and you can actually see them kind of spreading out, which is very, very cool. Okay, you can see it, says Tomo. That is fantastic. Great. Okay, so what I'll do is I'll leave this on split screen so you can kind of see these kind of evolving, which is very, very cool. Now remember, it happens in more viscous liquids. With the green, there's very little of that, because in water there's very low viscosity. Okay, all right, fantastic. Brilliant. So as I said, if you are doing this at home, please make sure you're already getting out the set for number 3. Now, number 3 involves a little bit of construction, which is fantastic. And by the way, also within the set, okay, it is not a coincidence that there is a violet pencil, a blue pencil, and a green pencil, which matches this. So please draw, okay, draw what you've actually seen. So especially the MEL Science guys have actually made sure that you've got this sheet here. Okay, the glycerol water and the water, and also the glycerol on its own with the colours. Draw what you see in terms of these as well. Okay, so the little exercise for you guys to do at home. Owlie loves drawing, so we've already gone through lots of these. He's actually ended up doing them on the back as well, which is fantastic. So however you want to do it, that's absolutely fine with you guys. Okay, fantastic. All right, great. So let me move these out of the way. In fact, I can actually see, look at this, it's still moving. Can you see this? This is just incredible, the beautiful, beautiful structures that are happening because of these convection currents. As I said, the bottom heats up, the atoms themselves rise up and thus sort of spread, and they cool down and then sink as well. So we get this constant movement. And yes, that is the movement that we get within the oceans. Okay, and also that is the movement that causes the wind as well, which is very, very cool. So now I'm going to just make sure I clean these away nice and safely. There we go. And I will pop this one over here. Okay, brilliant. Okay, right, we're on to the last one, which is pretty cool. Now this one here, okay, what we're going to be looking at is a coryloscope. Okay, now a coryloscope was actually invented by Paul Matisse, the artist, in 1966. And the Greek, if you translate from the Greek, it means an object to see beautiful flows. Okay, so essentially it's to see the sort of beautiful flows that happen. Now remember, in this whole thing we've been talking about this the rheoscopic fluids, which is so that we can see these currents, because the problem is you can't see them. We can't see the wind, okay, but we can see their effects. So by adding this wonderful, wonderful sort of metallic ink or dye here, it allows us to actually see these flows nice and easily. Okay, so when an object spins, right, we're going to be looking at this. And let me just show you. When an object spins like this, accidentally clicked the wrong button, sorry about that. As I said, live shows, technical. Now if you have a bicycle wheel, okay, so you spin a bicycle wheel, remember, if you've got the inside here, the spokes connected to the outside. Now the inside of the wheel turns much more slowly. Say for example it's rotating every 2 seconds. The outside of the wheel has a lot further to go. Okay, so what's happening here, the inside of any wheel is rotating slower than the outside of the wheel, because the outside in the same amount of time has to go much, much further. Okay, so and he will. Now the same principle happens with planets like Jupiter. Build a device now that allows you to see this. Okay, so we're going to do, now obviously you can finish off the building yourself, but I'm going to move through this fairly quickly just to make sure we have enough time. I'm sorry, we've had a few little technical things, but here's the Rheoscope here, and what we're going to do here is this. Now within the set you'll find there is a plastic holder like this, and there will also be a lid to that as well. Now where did I put my lid? I put it here, sorry about that. There we go. Okay, so I've got my lid and my piece here, and so let me make sure that you can see the tabletop. So what we've got here is this little plastic container, like a petri dish, and we've got the lid there. Now what we're going to do is we're going to take our green metallic colouring, okay, so the green metallic colouring, and we're going to put 3 spoonfuls into here. So I'm going to put 1, 2, 3. Okay, 3 teaspoons into there, or not teaspoons, sorry, little spoons. Okay, and then what I'm going to do is I'm going to add some water to this. So I have my water here. Okay, there we go. I'm just going to add there, and look at all the beautiful colours that come from there. Okay, it's actually very, very cool. Okay, so we'll just press that there, and we're just going to fill it up to the brim. Okay, so you fill it just up to the top. Now be careful. Now this is actually very important. With the set, okay, comes these absorbent sheets. Okay, so what I'm going to do is underneath this, very carefully, I'm going to place the absorbent sheet. Now there's a reason for that, because when we clip the lid on, sometimes a little small amount will get, and we want to obviously protect the table. Now of course you've got the black covering, which is absolutely fine, but we want to make sure that we absorb any extra so that we don't end up damaging the table. Owlie has reminded me. Fantastic. So I'm just going to do that. There we go. So that is there. Now, what we then do is we take the top of this and we clip it on. Okay, so we actually put it in there. Now, a little bit of liquid has come out there, but we're going to push that down. Okay. There we go. Perfect. Okay, and then what we can do is we can just pat it dry. Okay, just make sure that it is dry. Now I know we've got about 5 minutes or so, so we should have enough time to do this. But as I say, you can always finish off yourselves if there's any problem. But now, right, what I've done is I've clipped that on there. Okay, and we've wiped it dry. There we go, perfect. Now, it says here, remove our gloves, because it makes it a little bit easier. Okay, and I'm just going to pop this there, and that should be dry now. Okay, so I'm just going to pop this over to one side for now. Now, I'm going to take these wooden pieces. Okay, now within the set here, there's a small envelope which has these little nuts and bolts. Okay, and what we're going to do, I'm going to pull these out here, and what we then do is we take the circle with the hole in the center, and we just place this through here. Okay, so we place these on, and you can see we have the nut and bolt will fit together to kind of hold it in place. So just, it's a little bit fiddly, so you might need a bit of help with this, but we can just screw that on. Okay, now I haven't fully tightened it yet. I'm just going to put all through 3 of those through here. Okay, so let me just do that. I'm just going to put that on there, and I just want to start, here we go, twisting that one there, and I'm going to take the third one and again place, and remember they all have to go into the same side. So we're just going to do this. Now, as I said, the Rheoscope was invented by Paul Matisse, the artist, in 1966, and essentially is an object to see beautiful flows. Now, in order to tighten these, we've also got a little spanner here. What you do is you place the spanner over there we go, over the nut, and we can then just twist this, and it should tighten. Okay, we just tighten those like this. So we use the little, there we go, spanner, and we place that over the top here. Okay, place it over the top here, and we just turn that, and it should tighten nice and clear. Yeah, perfect. All right. Cash thought Jupiter. Dad said Saturn, not bad. That's okay, guys. Well done on this. Perfect. Storm is about the size of the Earth. Yes, exactly. Massa, I have to say, I think it's even bigger. Right, perfect. Okay, brilliant. So we've got this now. Now what we need to do, okay, is we take our device. Now make sure it's been clipped on properly, please, okay? And what we then do is we turn it upside down and we place it onto the top here. Okay, so place it onto the circle here. Now you can see this is all looking very silvery. That's okay, that's all part of it. Okay, now what we then do is we take this, so this circular part with the smaller circle in the center, and we place that over the top there. Okay, and then what we then do is we twist these in here, okay, into the holes, and we should be able to place those on there. Now I'm just going to make sure I do this nice and quickly. Obviously you guys can finish up yourselves, and we can actually use the little spanner here to twist them just to make it nice, and there we go, perfect. So nice and tight. Now remember, you don't have to tighten them too much, so please obviously don't break the thread, but they should get to a point where they're quite tight. So what you might find, and I found this before, is if you tighten these too much, they end up sort of clipping and becoming looser again. So just tighten them to the stage where they're just tight enough to stay in place. So what you'll feel, here we go, is you might feel it click. There we go. So that's nice and tight there. Okay, we're just trying to make sure that we keep these two things together. Okay, all right, fantastic. Now next, as the last little bit, we take these two pieces here, okay, and we place them, this one with the place on the bottom, over the top here. I'm aware that we finish in about a minute or two, but as I say, and then the last little bit is this, okay. We have our ball bearings. Oh, there we go. And you place this, okay, over the cross of these, okay. So we're going to take out, there we go, okay, the bearing, okay. And then what we do, okay, is this. You take your little rubber ring, and there should be a sticky part here, and you place that into the small circle in the wood, nice and clear like that, and that should stick in place. Now, how are you guys getting on at home with this? I realise I've made a bit of a mess. Sorry, Ali. There we go. He's looking at me going, what are you doing, Sparky Mark? You know, there we go. I'll make sure I clean everything up. As I say, be careful with your tables. All right, fantastic. Good. How are you guys getting on with this? Okay, good. I can see lots of people saying that's good. And then you push this down here and you place this onto, so in fact, actually, I think it's probably easier to turn this upside down and place the bearing onto or into the rubber ring here. And then what we can do is we can turn this over, okay, and you can actually spin it. Okay. Now I can see a little bit of liquid there, and then the moment you stop it, have a look at what's going on here. Look at this beautiful, beautiful flow here. Okay, and so again, if you spin it like this and then just stop it, have a look at the beautiful flow that's created there, which is fantastic. So I obviously let you guys have a look at that for yourselves. Ali, do you want to see this? Yeah, he wants to see it too. So what we'll do is I'm going to do a little video. As I say, if you make any videos or any pictures, please do send them to us. So, right, so what we're going to do here is I'm going to spin this. Okay, we'll just spin this round here. Okay, and then I'm going to stop it. There we go. And I will play it for you here. And you can kind of see it in slow motion spinning around. Look at this, Owlie. Very cool. He loves these. So fantastic. Now, how are you guys getting on at home? Hopefully you've been able to do it. I will put my split screen there so you can see. Hopefully you guys have been able to make yours at home, which is amazing. And by the way, this is the same principle as I say as Jupiter, which is very, very cool. Now, for any of you guys, if you would like to receive a personalized certificate for attending this session, we will actually send you, Owly and I will actually send you a postcard. Obviously, we'll do it through MEL Academy because they'll have, then you can complete the following form with your contact details here. So we will send you, we'd send it to MEL Science, don't we? And then they will send it to you guys. So if you're interested in receiving a personalized certificate for attending, and we'll write you a little personal message and things like that, then please click the link that is in the chat right now, okay? Because, and you know, the big thing here, guys, is I know we've gone a couple of minutes over. I apologize for the technical issues, but I wanted to make sure that you got the full session here. The big thing here is that you can see us. I know you've come to our house here in London live, which is fantastic, but we can't see you guys. So I apologize for that. But one week we can make it a little bit better, a little bit more personal is, as I say, we will send you a personalized certificate for attending this. And Ebne said, can we download these videos? I think we can. You can watch them online, but I think Kelsey can let you know how to do that. Sorry, obviously with this video, there'll be a little bit of stop in the middle because we had a technical thing. Ebne had asked about, are atoms God particles? Just quickly for anyone who does want to know, atoms are made of much, much smaller particles, okay? And there is a particle called the Higgs boson, which some people have nicknamed the God particle, but it is not. It doesn't actually have anything to do with a God or anything like that. But essentially, it is a theorized particle that gives the mass to atoms, or why atoms have mass. Anyway, now let us know. What do you think about this session, Owly? Oh, Owly says best session ever. Best session ever? Yeah, he loves it. I think he loves the colours. I know we had a bit of a technical thing. You guys were amazing about being so patient. They were amazing at being so patient with us. Remember, we couldn't focus the camera. As I said, one of the great things about live sessions are that we, you know, we can answer your questions and things like that. But you know what? One of the things are live sessions, you know, they're going to be technical things. I'm glad we could get it sorted and you could actually see what's going on there. Yeah, guys, thank you again for being so patient with us. I know they were such a wonderful patient, and they had great, yes, Ali says you had great questions and great responses to all the polls and things like that. So fantastic. Now, I hope you've enjoyed rheoscopic fluids, which is just really cool. So we can actually see the flow. Please experiment for yourselves. Try spinning them at different speeds. Maybe also try and fill this one here with the blue one and see what else happens. But we will leave that to you guys to try for yourself. And I can see that most of you guys have already pressed the poll there. So thank you so much for being there. I'm glad you loved it. We love this lesson. I loved having you guys there. We love having you, don't we? Yes, and for tuning in from all over the world. Massa, I'm glad you loved this session. Best session. Tomo, lovely to see you. And Liam, we loved it. Upcoming obstacles part of learning. No worries. Yes, you are right. Overcoming the obstacles is a big part of learning. So thank you. And also thank you so much for Kelsey, who, you know, now we've gone 5 minutes over. This is her... Kelsey's really great. Thank you so much as well. All right, lovely to see you guys. Thank you, Owly. Owly says goodbye. I say goodbye, and we will see you again very soon. See you next week for another live session. Take care, guys. Bye-bye.